Imagine waking up and there's nothing but absolute suffocating darkness.
Just total sensory deprivation.
Right. You don't know your name, you don't know where you are, you try to move, and you realize your muscles are just incredibly weak.
Like they haven't been used in years.
Exactly. And robotic arms start moving around your body in the pitch black. And then as your senses sort of painfully adjust, you realize the absolute worst part.
Which is that you aren't alone.
Yeah. You are sharing this tiny, dark space with two dead bodies.
It's a scenario designed to break the human mind because we rely on context. You know, you strip away sight, memory, context. It's unparalleled psychological terror.
And the context of this specific nightmare is the ultimate punchline. Because as the fog in your brain slowly clears, you realize you aren't in some, I don't know, secret underground bunker.
No, you're definitely not on Earth.
You are 12 light years from Earth. And humanity, like everyone you have ever known, every society that has ever existed, might already be dead.
We're talking about a situation where the stakes are absolute, waking up at the literal edge of human existence.
So our mission today, in this deep dive, is to trace the anatomy of that exact apocalypse. We are looking at the detailed, terrifying account of Project Hail Mary.
We're basically going to reverse engineer an impossible cosmic crime scene.
Right. We want to break down exactly how you, the listener, could theoretically end up 12 light years from home in a desperate final gamble.
We have to look at the astrophysics, the brutal politics, and the sheer terror of a dying sun.
And to understand a crime scene 12 light years away, we have to start with the victim of the crime.
Right.
Our very own sun.
Yeah, the investigation absolutely starts right here in our local solar system.
So let's bring it back down to Earth. The sun is, the backdrop of our entire existence. It's 150 million kilometers away, and we just take it entirely for granted.
We do. The illusion of stability is incredibly powerful. I mean, the sun is a main sequence star. It's a massive nuclear furnace fusing hydrogen into helium.
And it's been doing that reliably for, 4.6 billion years?
Roughly, yeah. And every single mechanism of the Earth's biosphere is tethered to that constant output of energy. Our weather patterns, ocean currents, the forest providing oxygen, they all depend on it.
But then scientists notice a shift. And it's not some sudden dramatic darkening of the sky, right?
No, it's a tiny, almost imperceptible dimming, just fractions of a percent.
Which is why the initial reaction is just pure denial.
Well, the scientific community's first response is always extreme skepticism. Astrophysics operates within strict paradigms. A star doesn't just drop in luminosity on a timescale of months.
Right, stellar evolution takes millions of years.
Exactly. So when satellites measure a drop in solar irradiance, the immediate assumption is sensor degradation, software issues.
Okay, let me stop you there, because this is where the human psychology really fascinates me. It's like discovering the foundation of your house is slowly turning to dust.
That's a great way to put it. You don't notice it on day one.
Yeah, but eventually the roof is going to cave in. So why does it take so long for the world to panic? Why do scientists default to blaming their own multi-billion-dollar equipment?
It's Occam's razor. Sensor drift, or atmospheric interference, is statistically millions of times more likely than the sun violating the known laws of thermodynamics.
So you have to meticulously rule out the mundane before you can even entertain the impossible.
Precisely. So they recalibrate the instruments. They cross-reference data from different observatories, satellites, terrestrial telescopes in Hawaii and Chile.
But the data holds up. The telescopes aren't broken.
No, they aren't. The sun is actually losing energy. And worse, the dimming trend is accelerating.
And that realization introduces the boiling frog scenario, the systemic compounding failure.
Because a fractional drop in solar energy doesn't just mean you need a thicker sweater, it disrupts the entire global energy budget.
So let's unpack the actual timeline of that collapse.
Yeah.
Because reading the source material, it's a terrifying domino effect. What happens first?
The immediate casualty is the global agricultural system. Human agriculture is hyper-optimized for our current climate window.
Right.
So a drop of just a few degrees in the global average temperature means frost arrives weeks earlier in the autumn, and it lingers weeks later in the spring.
Which shrinks the growing seasons.
Drastically. You can no longer grow wheat in Canada or parts of Russia. Corn yields in the American Midwest just plummet.
Oh, wow. So we're talking about a massive caloric deficit for the entire planet.
Yes. When crop yields decline like that, you get catastrophic supply chain failures, food shortages, prices skyrocket, and the hoarding begins.
Let's be real about the economics here. I mean, what is the value of currency when the grocery store shelves are empty and will literally never be restocked.
It drops to zero. You're looking at complete economic collapse. Governments would fall within months once the food riots start.
Because the math is completely unforgiving.
Entirely. Based on the dimming models, scientists project that half the human population starves to death within 2 decades.
Half the population.
Yeah. Followed shortly by the rest as the oceans actually begin to freeze. Extinction isn't just a possibility, it's a guaranteed mathematical output.
Okay, so once the observatories accept that the equipment isn't faulty, they have to find a cause. The sun isn't just getting tired. Something is physically doing this.
And what they find completely rewrites the rules of biology.
They find the Petrova line. Break that down for us. What is the Petrova line?
So a Russian scientist named Irina Petrova uses spectroscopy analyzing the spectrum of light and discovers this faint, continuous arc of infrared radiation.
Extending from the sun, right?
Extending from the sun all the way to the planet Venus.
Wait, like a physical braid of light connecting the sun and Venus.
Like a massive, invisible river of energy. And when scientists send a probe into this line to capture a sample, they expect gas or plasma, but it's biological.
They find living microorganisms in the absolute vacuum of space.
Yes, an alien microorganism, and it's actively migrating between the sun and Venus.
I need to pause on how insane that is. Space is a void. It's bombarded by lethal ionizing radiation. It's near absolute zero in the shadows, intensely hot in the direct sunlight.
It's completely hostile to life.
Right. Life as we know it needs liquid water, atmospheric pressure. How is a bug surviving out there?
It forces a total reevaluation of biology. The scientific community names this organism Astrophage, which literally translates to star eater.
Star eater. That is chilling.
It is, because astrophage is incredibly robust. It is an exterior membrane that can withstand massive temperature fluctuations and block cosmic radiation.
But the truly terrifying part is how it eats, right?
Exactly. It eats stellar energy. It absorbs photons and converts pure electromagnetic energy into physical mass using Einstein's mass energy equivalence.
E equals mc squared.
Exactly. And when it needs to move, like traveling from the sun to Venus, it converts that mass back into energy and emits it as infrared light.
Like a microscopic rocket ship.
Exactly like a rocket. It absorbs energy at the sun, travels to Venus to get carbon dioxide to reproduce, and then the offspring travel back to the sun.
Okay, but here's the thing. Even if these bugs act like tiny rockets, the scale doesn't make sense to me. The sun is massive. How do microscopic bugs block enough light to freeze the Earth?
2 words. Exponential growth.
The compounding math.
Think of a pond with a lily pad that doubles in size every day. If it takes 30 days to cover the pond, on day 29, the pond is only half covered.
So people don't notice the danger until the very last day.
Right. Astrophage reproduces exponentially. 1 cell becomes 2, 2 become 4. Given the infinite energy supply of the sun, the population just explodes.
So the sheer density of trillions of these microbes forms a literal cloud that blocks the star's radiation.
Yes. Humanity is dealing with an alien pathogen. The Earth is infected.
Here's where it gets really interesting to me. We spent decades, preparing for nuclear war, building underground bunkers.
Fretting over climate change.
Right. Or mapping near-Earth asteroids.
Yeah.
And ironically, we're going to be taken out by a space bug doing exactly what yeast does in the Petri dish.
It's a completely out-of-context problem. Our traditional human systems are just entirely unprepared for a stellar pathogen.
Which brings us to a massive bottleneck. The clock is ticking. The models prove the Earth is going to freeze.
Extinction is immediate.
And governments look at this and realize that standard operating procedures like committees, political negotiations, summits, they take years.
Years that humanity absolutely does not have.
So they do something unprecedented. Enter the dictator of Earth's salvation, Eva Stratt.
Yes. One woman granted extraordinary, unchecked authority to save the world.
Her mandate is basically whatever it takes. She has unlimited resources, unlimited urgency. The survival of civilization becomes the planet's only priority.
It's a fascinating look at the sociology of an extinction-level event. Democracy and bureaucracy, those are luxuries of peacetime.
Right.
Stratt understands that in a crisis, popularity is irrelevant. Results are everything.
But I have to ask, what does this all mean for society? We basically hand over the keys to the entire planet to one person and say, do whatever you want. That is terrifying.
It is terrifying, but frame it as the ultimate trolley problem. A runaway trolley is barreling toward 8 billion people.
And Stratt has her hand on the lever.
Exactly. She doesn't have time to poll the passengers on how they feel about the lever. She doesn't fly ships or invent cures. Her superpower is cutting red tape with a sledgehammer.
There's a moment in the text that highlights this. She literally commandeers a United States aircraft carrier, not for war, but because she needs its nuclear reactors for a lab.
No requisition forms, no debate in Congress, just, I'm taking your warship.
And what stops a superpower from just assassinating her?
The certainty of extinction. The world leaders know if they cling to their sovereignty, every human being will die.
So the psychological weight on her must be crushing. Every delay costs precious time. Every decision collapses industries.
She carries the responsibility of billions of lives. And part of that is assembling the greatest minds on Earth to solve the astrophage problem.
She drafts them. But the key to saving humanity isn't some famous Nobel laureate or a billionaire tech bro.
No, it's some man grading middle school homework.
Ryland Grace. I love this detail. It completely grounds the epic scale of the story. He's a middle school science teacher and a former researcher.
It's a massive contrast to traditional sci-fi heroes. The text notes that intelligence and expertise matter, but sometimes curiosity matters most of all.
He loves helping students understand the universe. He gets excited by ordinary facts. Why is that specific mindset the exact cognitive tool required here?
Because hyper-specialized scientists view the universe strictly through their mathematical models. When Astrophage violates those models, they freeze.
They can't see past their own paradigms.
Right, but a middle school teacher's job is breaking complex universe-scale problems down into understandable pieces.
He strips away the assumptions. Let's poke it and see what happens.
Exactly. Grace's fundamental curiosity is what's needed. Because as they study the very monster killing them, they realize it holds a miraculous secret.
The narrative completely flips. Astrophage stores energy with unbelievable efficiency.
It outperforms virtually every human fuel source. It's the most powerful energy storage system ever discovered.
So the monster becomes the miracle.
What's fascinating here is the massive scientific irony. The organism threatening to end civilization is the very thing that will revolutionize human technology.
Because it breaks the rocket equation. Before, you needed fuel to push fuel, which kept us trapped in our solar system.
But Astrophage converts pure energy to mass and back again. It's the perfect interstellar fuel.
It's like finding out the hurricane that's about to destroy your city is somehow made entirely of jet fuel, and you can use it to fly away.
That's a perfect analogy. And they have a destination to fly to. Because astronomers make an incredible discovery.
Tau Ceti.
Right. They map the local stellar neighborhood and see that all nearby stars are dimming. Except one. Tau Ceti is unaffected. It's immune to the astrophage infection.
It's the control variable in this galactic experiment.
Exactly. It's a beacon of hope. They have to travel 12 light years to see if it hides a cure, a predator, or some environmental condition that kills the plague.
So humanity has a destination, and they have a fuel source.
Yeah.
But they have to build a spaceship designed to cross the enormous darkness between stars.
Project Hail Mary.
And the name is just so fitting. It's a desperation play in football, a final throw.
It signifies a complete lack of a backup plan. If this fails, everyone dies.
And it's a one-way trip. The crew may never return. They can only pack enough astrophage to get there.
It's an interstellar suicide mission, and Ryland Grace is placed on this mission, forcing him to confront his deepest fears.
They induce a coma to survive the journey, using relativity and time dilation. Which means, for the crew, it feels like a few years.
But back on Earth, decades will pass.
Which connects back to the opening of our deep dive. This is how Ryland Grace ends up waking up in the dark 12 light years away with amnesia and 2 dead bodies.
A tiny mechanical failure in the life support system killed his crewmates. The fragility of human engineering.
He is totally alone, the last hope for 8 billion people. But as his memory returns, his curiosity kicks in. He starts looking for answers at Tau Ceti.
And he finds the Blippe, an alien spaceship.
Humanity is not the only species threatened by astrophage.
No, another species from a different star system is there for the exact same reason.
And this introduces him to a friend unlike anything humanity has ever imagined. Rocky.
You're already an engineer.
The isolation of that dark room suddenly isn't as lonely as it seemed. But Rocky isn't just a guy with a bumpy forehead speaking English.
Not at all. Rocky's biology is radically different. His planet has high gravity, a superheated ammonia atmosphere, and is completely pitch black.
So they never evolved eyes.
Right. Rocky seas with sophisticated echolocation. His body is armored in rock-like carapace. Human temperatures would freeze him. His atmosphere would incinerate a human.
They have to communicate through a glass wall. How do you even talk to him? You can't point to an apple.
You use the universal language. Physics and mathematics.
I love this. A hydrogen atom is a hydrogen atom everywhere in the universe.
Exactly. Grace uses measurable physical constants like the wavelength of light to establish a shared dictionary.
Because Rocky speaks in musical chords, Grace writes a program to translate the math. They build a vocabulary word by word.
It's the perfect synthesis. Grace has human biological science. Rocky is a master engineer with advanced materials, but lacks radiation knowledge.
They become colleagues and friends. In the deepest dark of the cosmos, the shared language of science allows a middle school teacher and a blind alien to save their worlds.
Together, they find the secret of Tau Ceti.
Tell me about.
A microscopic predator that eats astrophage, they just have to breed it and send it back to their respective stars.
It's a testament to the resilience of human and alien curiosity in the face of the dark unknown.
Let's quickly recap the breathtaking escalation here. From a slightly dimming sun to an alien microorganism, to a planetary dictator, an everyday teacher, and finally, a desperate interstellar suicide mission fueled by the very thing killing us.
It challenges us to think about what humanity is capable of when our backs are truly against the wall.
And that leads me to a chilling question. A provocative thought not answered in the text, but something for you to mull over.
What happens if this was real?
Right. If we discovered a guaranteed extinction-level event tomorrow with a timeline of exactly 20 years, would humanity actually unite?
Would we pool all our resources under one leader like Eva Stratt to build a Hail Mary?
Or would we spend our final 20 years fighting brutal wars over who gets the last remaining scraps of a dying planet?
A very dark question about human nature.
It is. Are we the species that builds the ship or the species that fights over the scraps? Something for you to explore on your own. Thank you for joining us on this deep dive.
Stay curious.
We'll see you next time.